Good morning to all of you. I am Professor Neeraj Kumar Dhakar, Assistant Professor, EC Department, SIRT Bhopal. Now, today we will discuss about the types of signal and system. So, first we will discuss about the signal. So, we can say that the signal can contain some information, and we can say that we can transmit the signal source to destination with some information. So first we will see the application of analog and digital communication. So basically the major application of this area is communication, audio, video processing, image, video processing, analog communication, digital communication, mobile communication, and satellite communication. Because of the communication, we can transmit the signal from source to destination. So the signal may describe a wide variety of physical phenomena. It can be represented mathematically as function of one or more independent variables. For example, f of x by z, or we can represent it x of t. T is the time. For example, we can represent the time for the variable of x of t, frequency for x of f, and temperature, pressure, or any other signal. So basically the signal are basically two types: continuous time signal and discrete time signal. So the course will cover concept and technique associated with the continuous time or discrete time signal. Continuous time signal are defined as the continuous of the value of the independent variable. We will always be treated as a function of t. And if we are talking about, we can represent the continuous time variable by using the x of t, and a discrete time signal is defined as at a discrete time taken on only a discrete set of value, or it is defined only for the integral value of time. In the discrete signal will always treated as function of n, and we can represent it by x of n. For example, the speech signal as function of time, and atmospheric pressure as a function of altitude are example of continuous time signal. And the example of discrete time signal is closing stock market index in an example of discrete time signal. So we can see the example of continuous time signal. The x-axis is denoted by the time, and y-axis is denoted by amplitude. So each and every value of time we can get some amplitude, and in the discrete signal only we can get the some amplitude, only integral value of time. So next type of signal, for example, continuous time signal, also we can denote it by this expression. For each and every value of time we can get the some value, and in the discrete time signal only we get the value, or we get the amplitude, only the integral value of time. Next one is the periodic signal. So if we can define the periodic signal, so if signal is repeat itself by its fundamental time period, or by using some time of interval, so we can say that it is a periodic signal. In mathematically, we can represent it x of t is equal to x of t plus capital T, and capital T is basically the fundamental time period. So this is a signal. If this signal is repeated t 2t, 3t, and 4t up to so on. So we can see that this is a periodic signal with the fundamental time period of t. And also we can denote it in the discrete form. So x of n, if equal to x of n equal to x of n plus capital N. So where capital N is fundamental period in case of discrete time signal. Next signal is even and odd signal. Basically, mathematically, if we x of minus t is equal to x of t, then we can say that it is a even signal, or in case of discrete signal, x of minus n equal to x of n. So this is a even signal. And if x of minus n is equal to minus of x of t, so this is a odd signal. Basically, even signal is symmetrical about the y-axis, and odd signal is anti-symmetrical about the y-axis. Next signal is exponential and sinusoidal signal. So exponent we can represent mathematically x of t is equal to c e raised to the power at, c where c is the constant. So it is a depend on the value of a is greater than 0, then the exponent increasing, we can get the signal exponential increasing, and if the a is less than 0, then we will get the decaying exponential signal. So it is all about the signal. So thank you.